there. Right in the middle, see him? Where's the 0.84?
A little bit to the right.
Yeah, a little to the right. Go right this over here, 0.84. And we're going to shade this way. Everyone agree? Hey, don't worry. I'll make sure we practice a problem where it's less than. Last two problems. We keep doing more than. Let's do a less than. Everyone okay with this picture? That's rho. That's our p hat. This is your p hat. And that's your rho. Now, when I do the z-score, what would z be? Well, z would equal p hat. Don't worry, a lot of you are going to skip this step. I want to show you step 2. It would be z would equal my rho p hat minus the mean over the standard deviation for this thing. And you go, oh gosh, I don't feel like doing all this. Okay. But if I want to get the z-score, look what I'd have to type in. I would take the p hat, which is a what? 0.84. I would subtract the mean. Remember the mean was always here?
Mm-hmm.
That's that. But then I'd have to divide by the standard deviation, which is that. Well, a lot of you are like, okay, well, can I bypass that and just use the technology and go to the next step? Absolutely. But I do want to point out, if anybody in here is trying to get the z-score with this, and like to work with the z-scores, this is what you would compute for the z-score for this right here, this sample statistic. Cool? Yeah, I know. You're like, hey, I'm going to use the technology, and I'm now going to go to step 3. Cool? And you get your z-score this way. That'd be 0.84, that would be 0.8. This would be a square root of what? 0.8 times, Brianna, this would be that 0.2, and then this would be that sample size 75.
But you still have to take the standard deviation even if you
That's right.
do
Exactly.
the z.
So is it okay we use the technology and go to the next step? So here we go. Why don't we go to step 3? We're going to get the final answer. What's the probability? You're like, you're not computing that? Not if someone in this class is like, I want you to get that for me. I'll do it. We can do the math. We're like, hey, we'll go to this. Now I'm going to use that normal CDF, right?
Uh-huh.
All right. Normal CDF. And you all know there's 4 entries, true?
Yep.
All right, here we go. This is going to be the low p hat. The low p hat. This will be my
High p.
high p hat. The third entry has to be the mean of p hat. And the last entry has to be the
Standard deviation.
standard deviation of p hat.
P hat.
This is all we're going to do. And we're going to be very careful. There's going to be decimals in here, though. I mean, heck, what is the mean of p hat in this problem? They gave it to us somewhere.
0.8.
They have to give it to you. It's right there. That's always the mean of p hat. It's always dead center. There's your mean. I'm going to put it. So you get decimals in this problem. That's a 0.8. Well, look at this image. What's the low p hat?
0.84.
That's the thing I need you to be careful of, especially in testing situations. Because in letter B, look how they wrote this. Did they write out this 0.8? No, they wrote it like this, right? So you have to think on your own. I'm going to figure out what the sample proportion is. I'll take the lower number, divide the higher number. Cool. Hey, what's the high?
1.899.
2099. We'll use that for pos infinity.
No, you do that.
Now this is what I do. I type it out. Some of you like to get this number first. I like to type it out just like that.
Yeah.
The calculator will do this. I'm going to take this, hit this, multiply this, divide this. Okay? So that's what I'm going to do right here in this entry. For the standard deviation of this p hat, I am going to type it out. Here it comes. Square root, right? The calculator goes like that. Puts a parentheses. I'll start out with the row. What's the row?
0.8.
0.8. Cool. Now I'm going to hit the multiplication button. What was, Brianna, 1 minus 0.8? Do you remember? We found, yep, 0.2. And well, now I did the 1 minus p, right? 0.8 times 0.2. And then there's a division. See the division? Division, and be careful, don't use big N. Don't use big N. This is a lowercase n. What was the sample size?
75.
25. I wonder, Autumn okay with that? Yeah? Yeah? The key is we're just recognizing, I know this is going to be my standard deviation, but I'm going to be very careful typing those in. All right, let's see what we get.
So that's 0.0 46188
5%? Uh-oh, you getting something different?
Yeah.
Uh-oh.
I'm 3. Yeah, I got 9
I'll check the book too, because when I stole this one from the book.
0.8.
They got about 0.1922.
193.
All right, check it again. 0.1922, 0.193. But you got exactly 0.19, what was that to the 9?
3.
Huh? I'm gonna use yours then. Because yours is probably more accurate than that textbook. The textbook want to use a table. I'm gonna get to about rough 0.193.
It's 0.8 times 0.2 divided by 75, right?
Yep.
Huh, so why is that calculated?
Make sure you got square root.
Yeah, so the whole
I'm gonna look too. Can I look?
Yeah, sure. That's 0.16, right?
Yeah.
0.8 times 0.2, then divide by 75, and then you take the square root.
And you get square root of that is 0.0461. And then you're using 0.0461 here.
Uh-huh.
And then this, and this. Is that giving you that final answer here?
Oh, the final answer is
Awesome.
Oh, I'm just doing the.
I love it too.
Yeah.
Hey, I'm gonna point that out. He's doing it right. He was saying this number right here. If you did all this alone, separately, he's saying this number right here, the standard deviation of P hat was coming out to be about a 0.046, correct?
Okay, yeah.
Because that's good art. Some students like to get this number first, then type it in. Here's my warning though with these TIs. If you do that first, don't round it. You follow me? So if you want to do that separately on your own, write it out to, 8 decimal places. Because we can't round through our final step. That's why I like to type it like this. When the calculator is going to do all the math exactly for us. Cool. Hey, let's do another one. This time, let's make sure it has a less than. We haven't seen that in a while.
Sorry, can we just go back? Can you just reiterate what the question is?
Absolutely, this question. So here it is, what they're asking us to do. I just want to point out, all right, something is, you can tell the author made this stuff up. That's the word, that's what's funny about this. When they make something up, it doesn't make so much sense to us. We need problems that we can kind of relate to. So I'm going to make something up here. There's something in this world there's an 80% chance of, right? Let's just say 80% of people are nice. 20% are what? Just mean, grumpy people. All right, so this is our thing. So we're saying 80% of people are what? Nice people. And then someone went out and took a random sample of what? 75 people. Maybe they got them on this campus, right? Or maybe I should do professors. 80% of professors are nice. Someone went out and got a random sample of 75 professors. Okay. So here's the question. What's the chances out of those 75 people we selected? Professor Brown from the sociology department, etc. What's the chances that 63 out of the 75 or more are going to be nice people? And we're like, there's your odds. We're like, there's really like an 80% chance you're going to get some what? Some mean people in there. That's what we're saying, right? Yeah, good.
Where did the 0.2 come from?
The 0.2 is always going to be right here, the 1 minus that number. So it's kind of like this. Hey, pretend there's a 80% chance of rain today. Then we're saying that this number, 1 minus that value, 1 minus the row, is going to be 20%. We're taking 1 and subtracting it. That's right. And it's always 1 minus it. And if it helps, Erica, you can call it Q. I mean, seriously, because it's the letter after this in the alphabet, so it might make it easier for you to remember. You're like, I'm always going to get this NPQ here, but in this formula, you can think of it as a PQ over N. I'm serious. Like, some authors do this. They go like that, rho Q over N. Because it's easier and it's an you just go, how do I get Q again? And we're like, Q is always 1 minus the rho. If you find that easier. Okay. I'll write that down here, and we're just, for our class, let's always think Q is 1 minus P, or with this section, 1 minus rho. You could think of it that way. It might be, I find that easier to remember. This seems a little weird to me. All right. My next question. Letter C. What is the probability of obtaining, I'm going to erase this. How about x equal to 51 or fewer? 51 or fewer. So I'm going to erase all this. That's changed. I'm going to erase this. That's changed. I'm going to erase my picture. That's changing. I do want to point out what stays the same. And when we still have our checks, we're good. We're doing letter C. What's the probability of obtaining 51 or fewer from the 75 being nice professors? 51 or 75 are nice professors. We're saying 80% of professors are nice. Okay. Now, step one, we're going to look at this bell-shaped curve. Whoop. This is actually important. Where am I shading? Outstanding. Outstanding. We're going to shade this way, right? Do you remember who's in the middle again? It's still this what? This 0.8's in the middle, but you now have a 51 over 75. And can you find my error? Look. In my picture, I'm going to put a 0.8 here because that's in the middle. And you find my error, watch this. I put a gigantic 51 over here and go like that. That's not right. That's not a 51. Good job. Gary, outstanding. He's like, you gotta write this as a decimal. You gotta think of the sample proportion. That was outstanding. So when I'm gonna go off the side, just like he said, I would write this. What is p hat here? P hat is x over n. It's a 51 over, just figure out what this, what's this, what percent of these, from the 75, what's this sample proportion they're asking about?
0.68.
Awesome. Again, Autumn, I want to emphasize that I can't stand when this is a run-on decimal, because then we can't round it. That's okay, we just type it in here like that. If it's 0.33, just go 0.33333333, hit it a few times on your calculator. But you see how it stops? All right. So when I'm erasing this, that was wrong. This is a what? 0.68. You got a 0.68 here, you got a 0.8 over here in the middle. I've shaded to the left, and now I'm going to find my probability. I am bypassing step 2. Is everyone okay with that? Right? I could have done step 2 as what? Calculate the z-score, remember? I'm just going to put all this in here. This stays. Does everyone agree this stays? Look. Isn't the standard deviation of p hat the same? It does. Isn't the mean of p hat the same? This is now different. Look at this image. What's my low p hat in terms of this?
Negative 1 E99.
Negative 1 E99. What's my high p hat?
0.68.
0.68. All right, let's see what the odds are. I'll see what the odds are got. Can't even find it. I'll have to wait to see what you get. 0.004? Haley got 0.004. Anybody else get that? Oh wait, that's 2. That's right. 0.004. Would this be unusual? It would be unusual, everyone, for us to obtain 51 or 75, 51 out of 75 or less professors that are nice, right? For it to be that much. Because 80% tend to be nice, we're saying. Okay, so it'd be rare that you got that low. But in the math department, they're all mean, so that could happen. Right. If you change the question just the math department, this is now at like 0.1. Hey, the next question will be something we can relate to. Super job. Does someone okay with that? Hey, before I erase this, I do want to point out, every once in a while I get students who like to do step 1 and 2 entering. They like to use these, and when they get down here, they like to do z-scores. So if anybody wanted to see the z-score on this problem, what I would have done is, I'm gonna erase this, and I would have done this on this problem. I would have said z equals p hat minus the mean, which is that, over the standard deviation, which is all this. But as you can see, it's a lot of typing, right? See that? So it would be a point, where was it, 6.8? Minus 0.84? No, the mean was what? 0.8, right? Divided by the square root of 0.8 multiply 0.2 divided by 75. If anybody wants to see, well, what's that z-score? You can look at it. It can be positive or negative.
Negative.
Yeah, it'd be a negative z-score over here, and you'd get your negative z-score for this problem. And then you could do low z, high z, mean of z, standard deviation of z, and you can do it that way. Cool. But you got to be careful typing that in, Gary.
Right, so on the test, you are going to require us to do the full z-score, right?
No, I'm being honest, Gary. If you don't want to do step 2, you do not have to do this.
Okay.
No, Gary, I'm fine with that.
All right, no, I was just asking.
I think it's, we've done it a few times. It's a great question. You're not going to require us to do that. I think it's great that we're aware that everything is really based off this standard. These, everything's being normally distributed z-scores. But this is just facilitating our mathematics. That's what's important. We're statistically literate. We understand this is based off some z-score that can be occupied from a table, which is included in the textbook, but we're just going to use the technology to skip that step. I'm fine with that. Everyone okay with that? But Gary, some students actually like to go and get that z and see what it is. They like to do it, and they go in here and they're like, I'll hit the lights. And they're like, what's this? And I just want to show you we'll get the same answer. So this is the longer way. And I go in here and go, but boy, I really have to be